College Algebra. Welcome to your last lesson of the course. We're going to do the first half here in this video, and for the first half you're going to be graphing systems of linear inequalities. I say linear, some of them will be quadratic. We'll do a little bit of each. What you're going to be doing is solving these for y first. So go ahead and get your coordinate plane ready to go. If you have graph paper, this assignment can be done on graph paper. In fact, that's what I recommend. All right, we're going to start by solving this for y. And I'll be using slope-intercept form to graph it. Remember, when you divide both sides of an inequality by a negative, you need to flip your symbol over. So we have y is less than or equal to -4/3 x minus 4. Okay, as you start graphing, these symbols, you're going to be using a solid line. So when it has equal to, you'll graph that with a solid line. If it's not equal to, you'll be using a dashed line. All right, this problem is equal to, so we'll have a solid line. Y-intercept is -4. And then our slope's -4/3. 1, 2, 3, 4. 1, 2, 3. And we'll have a dashed line going through there. Hang on just a second. Okay. I don't have a good line tool with this program, so bear with me here. Okay, there's my line. Now, you don't have infinite solutions for this problem. You have a set of points that satisfy the inequality. Those points are either going to be up here, above the line, or they're going to be down here, below the line. So you'll either have the points above or the points below that satisfy the inequality. And by satisfy the inequality, those are the points that make the inequality true. So what you need to do is pick a test point that is not on your line. So you can pick any point that you want that is not on the line. I'm going to just pick this point here. It's not on the line. So 3, 3 is my test point. Now I will plug in 3, 3 either in for x here and y here, or I can plug them in up here in the original. It doesn't matter. Okay, so if I plug them in here, I'll have my y is 3. Is that less than or equal to -4/3 times 3 minus 4? So I'm going to work that out. So I'm questioning that. Okay, is 3 less than or equal to -8? And the answer is no, that's false. So it's false on the side of the line that 3, 3 is on. That means it will be true on the other side of the line. And so what you're going to be doing is you're going to be shading your solution set. So when I grade these, I'm looking for, did you show your work to solve it for y? Have you graphed it correctly? Did you graph it solid or dashed, as you should have? And did you shade above or below? So let's do the next one. Okay, so solve it for y. Remember, when you divide by a -2, you flip over your symbol. And then down 3, up 3 over 2. Because this one is less than, it will be dashed. So make sure when you graph your line, I can tell that you need it to be dashed as well. Now we have to figure out where we shade. So again, you're going to pick a point that's not on the line. And you can certainly use 0, 0 if you'd like, as long as that point's not on the line. So if I use 0, 0, I'm going to put 0 in for y. Is that less than 3/2 times 0 minus 3? Is 0 less than -3? And the answer is no. So I will shade on the other side of the line. So remember, you're shading where it's true. And in this case, it happens to be underneath the line. So this was false. This region will be true. All right, this one brings in a quadratic with a line. So what we're going to do is graph the quadratic first. You might recognize it better if you write it this way. So it's an upside down parabola, shifted up 4. When x is 2 or -2, I have intercepts at 0. So, and then it's upside down and it's dashed. So that's what we have right there. Okay, I'm going to check now and see when I shade, am I going to be shading underneath that parabola or am I going to be shading up above it? And so I'm going to go ahead and work with the ordered pair 0, 0 and see where I shade my parabola. So 0, 0 is right here. Is 0 less than -0 squared plus 4? Is 0 less than 4? And the answer is yes. So it is true in the region underneath my parabola. So I will go ahead and shade that region. For the second part, I'm going to have to take x is less than y minus 1, and I need to go ahead and solve that for y. I prefer to have the y on the left, so I'm just going to flip my entire inequality over. And that says y is greater than x plus 1. It is also dashed, so I have a line that goes through 1 with the slope of 1, and it's a dashed line. So then I have to decide, am I shading above or below this line? So if I go with 0, 0 again as my test point, is 0 greater than 0 plus 1? Is 0 greater than 1? So I'm testing this out, and no, it's not. 0 is not bigger than 1. So 0, 0 is underneath the line, so I'm going to be shading above the line. So for the parabola, I'm shading above. I'm sorry, for the line, I'm shading above. For the parabola, I'm shading below it. Where they intersect, where my shadings turn to green, that's my solution set. So my solution set is this region right here where the two colors overlapped. And let's try number 4. And number 4 is actually number 55 on page 569. This one says, let me see, yep, this is the last one. So I remember this one from the past. You want to give yourself a lot of space. So as you mark off your axes, I'm going to purposely give myself a bigger scale. And if you do that, it will help you out as well. So I'm going to say that's 1 and that's 2. Same thing this way. Okay. This is just a pair of vertical lines, and my vertical lines are at -2 and 2. Okay, they're both dashed. In fact, every line in this graph will be dashed because they're all not equal to. All right, this says that I'm graphing x values in between -2 and 2. So I am shading inside of here. And then I'm going to graph this one. I'll use blue for it. It's saying that I want to graph the line y is greater than 1. So that is a horizontal line coming through at 1. And I want to graph all y's bigger than 1. So that's going to be above y equals 1, or y is greater than 1. Okay, then I want to graph this line here. I would like to have the y on the left. And remember, when you divide by a negative, flip it over. So that says y is less than x. That's a line going through 0, 0, 1, 1, 2, 2, and so forth. It too is dashed. And I need a test point above or below that line so I can tell where to shade. I'm just going to, I can't pick 0, 0 because that's on my line. So I'm going to pick this ordered pair right here, which is 2, 0. Is 0 less than 2? So I plugged my 2 in for x, my 0 in for y. Is 0 less than 2? And the answer is yes. So I'm going to shade now, let's see, let me pick up a different color, underneath my line. So purple. Okay, let me go back to my yellow. Okay, so I think you can see where the yellow, purple, and green meet. I am above the horizontal, in between the vertical lines, and below the purple line. This region right here is where all three colors intersect. And that, you guys, is your solution set. So when you do these, make sure I can tell make sure I can tell dashed versus solid lines, and make sure I can tell where your final solution set is. Thank you.